All right, 1.4. So 1.4, we're going to talk about functions and graphs. Again, just going to highlight certain things. Polynomial and rational functions. We're going to look at some properties of polynomial functions, polynomial regression using a calculator, and properties of rational functions, applications of polynomial rational functions. So a polynomial function is basically a long set of terms, and that long set of terms we can call a polynomial, and it has a degree of the polynomial and a leading coefficient and things we can look at. So properties with So all odd degree polynomials cross the x-axis at least once. All odd degree polynomials with positive leading coefficients start negative and end positive. I'm going to show you all these examples, so don't worry too much about it. I like to more show than talk. All odd degree polynomials with negative leading coefficients start positive and end negative. And the best way is to see it. If you have an even polynomial, it never intersects the x-axis. All even polynomials start positive, end positive, and have positive leading coefficients. All even polynomials that start negative, end negative, and have negative leading coefficients. So if I had graphed the odd degree polynomial, so let's talk about the function x minus 2. What will that look like? X minus 2. What's that going to look like? Linear, quadratic, what does it look like? Linear. Now, the degree of the polynomial is the highest degree. So this is x to the 1. What would the degree be? 1. That's the highest one. That's odd. That's what it would look like. Okay? X cubed minus 2x. What's the degree of this polynomial? 3. The highest exponent is 3. 3 is an odd number. Okay? So if I graph that, that would be cubic. It would look like that. Okay? Notice it starts going upward, it's downward, upward. Odd. If I asked you to graph x to the 5th minus 5x to the 3rd plus 4x plus 1, what's the degree of this polynomial? 5. Is that odd or even? Odd. Because it's odd, I know that one side's going to be going down, one side's going to be going up, just because it's odd. Just knowing what one looks like. And how many times across the x-axis depends on the polynomial. But there's characteristics that we know just by looking at it. And my answer to, instead of memorizing it, just graph it and you can see. And then after a while, they'll stick. Now, if I have x squared minus 2x plus 2, what's the degree of this polynomial? 2, odd or even? Even. Notice, this side's going up, this side's going up. They match. When it's even, that's what happens. Little things to note, just by looking at it. If I had 2x to the 4 minus 4x squared plus x minus 1, what's the degree of this polynomial? 4. 4 is even, so I know that the two ends will match. That's quartile. So remember, we're going to learn linear, quadratic, cubic, exponential. Quartile makes like a W shape. So if my dots look like a W or upside down would be an M, then I would choose quartile. So we get used to the shapes.
So the 4 decides like what shape it is, but if it's negative, it'll be the face down still.
But so the number in front is what determines which way it goes. Yeah, that's still the same. But the idea is that what degree is it, and if it's odd or even. That's the focus this time. Good point. If I had x to the 6 minus 7x to the 4 plus 14x squared minus x minus 5, what's the degree of this polynomial? 6. And is it even or odd? Notice both sides match. Just little things to notice, but you can always graph it. They're just little things to remind you of. So each odd started negative and ended positive, based on their opposites. The end of each odd polynomial moved in opposite directions. Each odd degree polynomial crossed the x-axis at least once. Each even degree polynomial started positive and ended positive. All had positive leading coefficients. Some even degree polynomials crossed the x-axis, some did not. The ends of each even degree polynomial moved in the same direction, both up, both down. Okay? Other observation, no graph cross the x-axis more times than the degree. So if the degree is 6, it will not cross more than 6. Changes in direction are limited to 1 less than the degree. Polynomials are continuous. Continuous or smooth. There's no separating. It's like drawing the whole picture without lifting your pen. Discontinuous if it jumps. So if we had 2 absolute value of x over x, that would be not continuous. If I had absolute value of x minus 3, it has that sharp corner. It's continuous, but has a sharp corner. But if I had x squared minus 4x plus 5, that is continuous and smooth. So again, notice some things where if we're dividing by an x, something could change. If we have absolute value, it has a sharp corner, but the normal polynomials are smooth. So now we're going to do cubic regression. So let's see if we remember the same thing. X is the number of years since 1960. Create a scatter plot for the data, find a cubic regression. So we're going to look at number of marriages, and we're going to do since 1960. So we're going to go to our calculator, and we're going to do cubic regression. You tell me, would you like your input to be 0, 10, 20, 30, 40, 50, or do you want to keep it to years? Do you want to input years, or do you want to input years since 1960? Both are fine, but we need to be clear. Years, so we're going to keep the years. So before we even touch the calculator, let's sketch. So looking at the data, what year should we start with? And what year should we end with? And what should we count by? So before I move on, we're going to put date. We agreed 1960, 1970, 1980, 1990, 2000, 2010. Again, we sketch so we understand the problem. And we're looking at number of marriages. So 1960 all the way to 2010, counted by tens. We'll go back to the data. Looking at marriages, what's the lowest number? 6.8. What's the highest number? So what do you want it to start and end with? What do you want to start with? Maybe 5 or 6. So we start with 5, give it a little space. How high do you want to go? 11, 12, let's say 5 to 12. Okay? Again, just looking at the data. So I'm going to start with 5, 6, 7, 8, 9, 10, 11, 12. Okay? So this is marriage and divorces per 1,000 population. Okay? Now, we're going to practice cubic regression. And we're going to practice our calculator. So, every time we start a new problem, I want you to go to y equals and clear everything out. Clear the equation in y1, and let's even turn the plot off. Go up to it, push enter, and it will unhighlight. So let's start with a clean calculator. Plot 1, plot 2, plot 3 are all unhighlighted. Okay? Now, we're going to put the data in the calculator, but we're going to use list 3 and list 4. I want you to go home and practice. So everybody hit stat, number 1 for edit. And in list 3 and list 4, make sure there's nothing in it. We're going to put our data. So we said list 3, 1960, 1970, 1980, 1990, 2000, 2010. In list 4, 8.5, 8.5, 8.5, 10.6, 10.6, 9.8, 8.5, 6.8. So step 1, put the data in the calculator. Questions there? Once the data is in the calculator, everybody good? Stop if you need me to. Now, question? Mr. Doom? Okay. Now remember, step 1, put the data in the calculator. Step 2, tell the calculator we want a scatter plot. How do I tell the calculator we want a scatter plot? Second y equals, go back into plot 1, but this time we're doing list 3 and list 4. This time we're doing list 3 and list 4. So we're going to go to plot 1, turn it on, choose scatter plot. X is list 3, Y is list 4. So everyone push second y equals. Push 1 for plot 1. Turn it on, choose the scatter plot. But this time X is list 3, second 3. This time Y is list 4, second 4. So step 1, put the data in the calculator. Step 2, turn plot 1 on, choose scatter plot. X is list 3, Y is list 4. Good so far? Great. Something didn't work. Okay. Now press window. Let's look back at our sketch. When I go to window, what was my X minimum? 1960. X maximum? 2010. And we counted by tens. My Y minimum? Y max? Counting by? Once your window is set, press graph and put your dots. So hit graph. You should see that. Put your dots. 1960 was 8.5. 1970 was 10.6. 1980 was 10.6. 1990 was 9.8. 2000 was 8.5. And 2010 was 6.8. Now, if you got the dots, do cubic regression. See if you remember now, cubic regression. Before we did linear, then we did quadratic. This time do cubic regression. Stack, calculate. Now, again, practice. We only have a couple minutes left. How do we do all the regressions? What do I push? Stat. Then what? To the right for calculate. Which regression are we doing this time? 6. Now again, for me, X is list 3, Y is list 4. If you use a different list, you got to put in the different list. Go down to calculate and see if your numbers are the same as mine. Now, a couple things to point out. I'm going to finish in just 2 minutes. Number 1, look at that R squared. Is that good or bad? Really good. Close to 1. Now, here's the trick. There's the formula. AX squared plus BX squared plus CX plus D. Your job is to plug in the numbers. Listen carefully. Be careful. What is A? Wrong. A is not 8.7. Ooh, what's this 0, 0, 0 stuff? Be careful. What's e to the negative 5 mean? Start of the decimal, move over to the left because it's negative 5. Negative 5 means start of the decimal, go 5 spaces. How many zeros would that be? 4 zeros because you got to go past the 8. Be careful, and you'll know it. I saved you, but you would know it because when you go to graph it, that 8.7 would not work. 1, 2, 3, 4, 8, 7, x cubed. And we're going to end on this. I do apologize for a little bit over. You're getting your money's worth today. Take that, put it in your calculator, and it should go right over the dots. That's 0.4087 x cubed minus 0.523 x squared plus 1045.9x minus 697588.212. If that goes in your calculator nicely, you hit graph, you have your answer. Okay, I'm going to take attendance in a minute. So please hang out. I do apologize for going a little bit over. Let me finish this one, and we'll stop there. So I go to y equals, and today, 1, 2, 3, 4, 8, 7, x raised to the 3. X raised to the 3. Raised is above the division. Raised is above the division. Minus 0.523 x squared. Be careful where you put it. So raised to the 3 minus 0.523 x squared plus 1045.9x minus 697588.12. Be careful, type it in. If you typed it incorrectly, when you hit graph, when I check it to make sure I did it right, 1, 2, 3, 4, 8, 7, x cubed minus 0.53 x squared plus 1045.9x. 697588. Make sure I have it correct. Okay, and it will cross over the line.